Keniquel Holley, and today we are going to be doing the math at home. So today's focus for doing the math at home is, are you ready? Classifying two-dimensional figures. That is going to be our focus for today's learning, is classifying two-dimensional figures. So before we begin, I want to make sure you have everything you need for today's learning. So you will need something to write on and something to write in. So go ahead, grab your materials because we're about to jump into our learning for today. Let's start off with reading our first statement. A trapezoid is a quadrilateral because it is a polygon with 4 angles and 4 sides. I'm gonna say it's true. What do you think? You agree? So let's put true. So we're gonna say true for that statement. Let's read the second one. All acute triangles have 3 congruent sides. Ooh, I'm gonna say false. What do you think? You're gonna say false as well? Let's go with false for that one. I'm thinking that yes, it has 3 sides, but as far as the sides being congruent, if I'm not mistaken, congruent means like the same. Let's look at the third statement. The third statement says all trapezoids have 1 pair of opposite sides that are parallel. Let's say true for that one. Because I feel like that I know the lines go this way, and I know that those lines are parallel because they don't intersect. So, yes, let's go with true for that one. Let's go to the third one. A right triangle can sometimes be classified as an equilateral triangle. Yes, I'm gonna say false because I think about right angles, and when I think about right angles, I think of a square for some reason. And so I'm trying to picture, can I take a side away from a square and then it becomes a triangle? I don't think so. The fifth statement, let's talk about it. A square is always a rhombus because it has 4 congruent sides and 4 congruent angles. I'm gonna say false. I'm gonna say we know that's a square, but a square, that don't mean it's a rhombus. So let's say false. Just because they threw the word rhombus in, and the word rhombus kind of confused us a little bit. Let's look at our last statement. An obtuse triangle can only be classified as being either scalene or isosceles. No, I'm gonna say false. Let's say false. And what we're gonna do is, we're gonna dive into our learning activity. And when we dive into our learning activity, it's going to definitely let us know if we were right or if we were wrong when it came to our review. All right. Now that we have finished our review activity today, remembering our focus is classifying two-dimensional figures, let's jump into our learning for today. Today we're going to work on 2 different types of two-dimensional figures. We're going to do 2 different parts of the lesson. And our first part of the lesson is going to work with a graphic organizer of overlapping circles. So what I want you to do is, on your paper, I want you to recreate the graphic organizer that's behind me. And while you're recreating it, we're going to talk about some things that I have here on the wall. So let's talk about these two-dimensional figures. As you can see, we're starting off with quadrilateral. And what I want us to do is first talk about the definition, and then we're going to take those definitions, look at those definitions, and determine where do they actually fall in our graphic organizer. So one thing we can say is that the word quadrilateral. Start with that one. So when we talk about a quadrilateral, we're talking about a polygon with 4 angles and sides. So remember, it's a polygon. And remember our definition about polygons are closed-in figures. So it's a figure that when we draw the lines, it's closed in. There's no opening for anything to come out. Closed-in figures. So quadrilateral, a polygon with 4 angles and sides. The next thing we have is parallelogram. So when we talk about parallelogram, we know that it's a quadrilateral, correct? So we know it's a quadrilateral, but this quadrilateral is a little special. The opposite sides are congruent, meaning the same size or the same length, and parallel, meaning that they will never intersect. No matter if we continue to extend it the same amount of distance, they're never going to intersect. And the opposite angles are congruent. Let's look at this next one, rectangle. What can you tell me about a rectangle? I know you know. We've been working with rectangles for so long, we know that it has 4 right angles. You're correct. So when we talk about a rectangle, we know it has 4 right angles, but when we talk about them in our order of shapes, it is also called a quadrilateral because it has 4 sides and 4 angles. But in this case, we're going to also call it a parallelogram. So when we talk about a rectangle is a parallelogram with 4 right angles. Let's look into rhombus. So when we talk about rhombus, it's a what? You said it. It's a quadrilateral, but it's also a parallelogram. But on this one, it's a parallelogram with 4 congruent sides. Square. I know you know square. Square is one of those shapes that we always learn. All the sides are the same and all have right angles, which is so true. But we want to also tag on that it is a parallelogram. And we know how I just said that it's a parallelogram with 4 sides, 4 congruent sides, and 4 right angles. Have we heard that before? We have. We heard it when we talked about rhombus and rectangle. So for this definition, we said a square is a parallelogram that is a rhombus and a rectangle. We have trapezoid. And we talk about a trapezoid, what is that? Yes, it's also a quadrilateral because it has 1, 2, 3, 4. It has 4 sides. So we know that it's a quadrilateral. I kind of heard somebody say it's a parallelogram. Let's look at this. A trapezoid is a quadrilateral with only 1 pair of parallel lines. Let's see if we could take these definitions and apply it to our visual of this graphic organizer of overlapping circles. Some people call them Venn diagrams as well. So we can use that as well. So let's talk about our actual graphic organizer Venn diagram, overlapping circles. We know the overarching circle. The big circle is going to be called what? Quadrilaterals. And so we're going to put quadrilaterals inside of our large circle, meaning everything in here is going to be a what? A quadrilateral. You got it. So now we know that everything in here is a quadrilateral. Let's talk about the 2 circles, or the circles that's directly inside the large overarching circle. So here's my overarching circle. And the next 2 circles that's directly inside is this one and this one. Notice one is small and one is large. And we see that because the large one also has something going on the inside. But we're not there yet. We want to just talk about the 2 circles that's directly inside of the overarching circle. So this one and this one are both called quadrilaterals. So what quadrilateral can we put here and what quadrilateral can we put there? So let's talk about the small one. It's a quadrilateral with only 1 pair of parallel lines. It's a quadrilateral. And right now, it could go in either one, right? Because this is a quadrilateral and this is a quadrilateral. Let's just put it here, just to be, because it's the first one. So remember we said that was a trapezoid. And we're going to put the shape there so that way you can have it as well. So that means this one will be what? The next one that says a quadrilateral is our parallelogram. So in our parallelogram, we will put that here. Parallelogram. And it's great to put our figures there as well because it kind of helps us just remember what it is. But one thing is that now that I sit back and I look at my definitions and I look at my chart, we actually placed them in a great spot because these other ones are going to have to be the other shapes. And if you notice by looking at the definition and also thinking about it, these are also called what? They're also called a parallelogram. So they're a quadrilateral and they're a parallelogram. So that's where these circles have to be. So trapezoid is kind of by itself because it's not a parallelogram. But this is saying parallelogram also has some other shapes inside of its circle. But I only see 2 circles. And we only use parallelogram, quadrilateral, and trapezoid. We still have 3 shapes left. So let's talk about overlapping circles. If you notice that this circle and this circle overlap, that means that this centerpiece also lies inside this circle, but it is also inside this circle. So that means whatever we put here has to be okay with being called this, and it also has to be okay with being called that. So let's talk about it. And I see you on your paper and you're already starting to write because you have that idea. If we look at our definitions, the square tells us that it is a rhombus and a rectangle, which means that it is 2 things, or we can name it 2 other things besides square, at least. So I feel like it's safe for us to say that square will go in the middle because this is saying that this square can also be called whatever I put this is. And the square can also be called this. So let's talk about those other 2. We have a rectangle and a rhombus. Does it matter which place we put it? It doesn't, because they both fall inside of the parallelogram. So let's just call this the rectangle. And let's label this one the rhombus. And now that we have all of these shapes inside of our graphic organizer, let's actually go back to the graphic organizer and read it using our understanding of the shapes or the figures. A trapezoid can also be called a quadrilateral. That is true because a trapezoid is a quadrilateral because a trapezoid has 4 sides. And it has 4 angles. Great job. A parallelogram can also be called a quadrilateral because it has 4 sides and it also has 4 angles. But a parallelogram cannot be called a trapezoid because if you notice, their circles don't even interact. So we know they are considered 2 different types of figures inside of this big umbrella of quadrilateral. So now let's go here. A rhombus. A rhombus can also be called a parallelogram because the opposite sides are parallel and the opposite angles are parallel. But it can also be called a quadrilateral because it has 4 sides and 4 angles. Yes, you see how this works. Let's jump to rectangle. A rectangle can be called a parallelogram because it has opposite sides that are parallel. And the opposite angles are also parallel and congruent. And the opposite sides are congruent. So that is why it can be called a parallelogram. But a rectangle can also be called a quadrilateral because it has 4 sides and 4 angles. But this square, the square can be called a rhombus because it has 4 congruent sides. Yes. And a square can be called a rectangle because it has 4 right angles. That is correct. But a square can also be called a parallelogram because it has opposite sides that are congruent and opposite sides that are parallel. Yes. And opposite angles are congruent. We got this. So a square can also be called a quadrilateral because, yes, it has 4 sides and 4 angles. So this activity was not really difficult once we took a look at the definitions and actually paid attention to what the definitions said. So what I want you to do is I want you to get a good look at our graphic organizer, and I want you to get a good look at our definitions. We are definitely going to be able to use these definitions and these graphic organizer for a lot of our work today. So make sure that you have this graphic organizer written down and you have the definitions. Even if it was just putting those important parts of the definitions, make sure you have them somewhere because you're going to need that for your practice on your own. Now let's talk about some triangles. So when we talk about these triangles, one thing we have to do is we have to first take a look at the triangles that we have. So in our first box to our left, for our first section, we have a triangle which is called an acute triangle. Say it with me. Acute triangle. Yes. Underneath acute triangle, we have a right triangle. Say it with me. Right triangle. Yes. And then our bottom one, we have an obtuse triangle. Obtuse triangle. Awesome. So then in our second column, in the top right, we have an equilateral triangle. Equilateral triangle. Awesome. And our next one is called an isosceles triangle. Isosceles triangle. Yes. And our last one is called a scalene triangle. Scalene triangle. Awesome. And if you notice, the triangles all look different with the exception of maybe 2. Those 2 kind of look alike, but they're not. They're different. And I kind of heard somebody say, one look a little bit larger than the other. You're correct. One is a tad bit larger for a reason. So let's go ahead and talk about our angle chart. But the first thing I want us to do is we want to talk about these 2 columns. And why did I put the names of them up the way that I did? Well, these 3, acute, right, and obtuse, we have heard those words before when we were classifying angles. Yes. So this section is going to be classifying the triangles by its angles. And this side is going to be classifying the triangles by its sides. Remember I told you the word lateral earlier meant sides? Same thing. So this side of our angle chart is going to classify the triangles by its sides. So let's talk about our angles first. The triangles dealing with angles. Acute. When we talk about acute means, yes, acute means that it means the angle is less than 90 degrees. And I remember when we learned about 90-degree angles, we talked about putting a perfect square in the angle. And it should make a perfect square, or somebody might have told you it makes the capital letter L. what I'm going to do is I'm going to place this square inside of our triangle to determine, are the angles acute, right, or obtuse? So we're going to start with this first angle. Always taking the paper and placing it in the corner and placing it there. If you notice, the angle directly lines up with the bottom, but then it crossed through it, which means that it is less than 90. If it was 90, it will be directly next to it. Awesome. So we know that this angle is acute. Let's talk about this one. This angle is also acute because, again, you see the line goes through it. Sometimes it's a little difficult doing the angles when they're upside down. So let's talk about this one. So I put it, line it up, make sure I line it up, and I put it down. And if you notice, it goes through. So this angle is also an acute. So when we talk about acute triangles, it tells us that an acute triangle has 3 acute angles. That is why this one is called an acute triangle. So we have one down. Let's talk about the right. So when we talk about a right triangle, again, we want to take that rectangle, that square, whichever, and we want to go and place it inside of our angles. And we're looking for a right angle. So if I put it here, I notice that it cuts through, so it is an acute angle. Awesome. So then I take it off, and I say, well, let me go try the next one. So I put it here, and same thing, it cuts through. So it's, again, not a right angle. So then I go and I place it here. And what do I notice about it? Yes, it is, and I guess I would have put it straight. It fits perfectly. So that tells us that we have at least what? There's one right angle. So let's talk about the definition for a right triangle. A right triangle must have at least one right angle. So an acute triangle, 3 acute angles. But in a right triangle, they only need one. One right angle, and it's a right triangle. Pretty simple. Let's talk about this last one. Here's my square. We're gonna go in and we're gonna try to see what kind of angles we have. So I'm gonna start here, lining it up. And if you notice, this triangle has a little bit of a tilt, so I have to tilt the paper as well. And when I put it up, what do you notice? It is an acute angle. That is so correct. So let's try this one. That one is that is an acute angle. You are correct. Let's try this one down here. Again, it's tilted, so I have to tilt the paper to make sure that it completely lines up with the base, with the angle, with one of the rays. So I have to line it up with the ray. And I lined it up. What do you notice about that line, that other ray? This ray shoots out. It's not close to it. It doesn't go through the box. It doesn't line up with the box. It actually shoots outside the box. So that means that it is more than 90 degrees. So this tells us that with an obtuse triangle, all we need is one obtuse angle. If it has one obtuse angle, guess what? It's an obtuse triangle. And so that's where we have this. So now we have 3 acute angles, 1 right angle, or 1 obtuse angle to classify these 3 triangles. So now let's talk about this one. I'm going to actually have to do some writing on this one because this is talking about sides. So we don't really have any particular shape that can talk about the sides. So I'm going to use the marker. Equilateral. Remember we broke the word up before. We said that equilateral means what? The same. You are correct. So in order for a triangle to be equilateral, all three sides must be the same length. And to know that they're all the same length, you will see three markings on the shape. So on the figure, these markings, and it has to be the same marking, will let you know that that figure is equilateral. And the reason why it's equilateral, because if you notice on this side, I only have one chevron or asterisk. They all call them different names. This one I'm just putting a dash. So this side has one, this side has one, and this side has one. That lets us know that whatever the measurement is for this is also the measurement for that, which is also the measurement for that. So all three sides have the same measurement. That is an equilateral triangle. Isosceles triangle. Isosceles triangle means at least two congruent sides. At least two congruent sides, which means that on your shape, you will have two sides that have the same marking, at least two. So on this one, I will put two lines to represent that that side is a specific length. I'm going to put two lines here to represent that this side is a particular length. They both have two markings, which means that they are the same size. Whatever the measurement is for this side, it's the same measurement for that side. But because it only have at least three, this one can have a different marking. And if you notice, I put one dash because that means this side is a different measurement than these two sides. I know, it's pretty simple once you get an understanding of the picture and the markings on the picture. But one thing, before we move on, let's talk about these two words, at least. What does that mean? Yes, that means at the bare minimum. At the bare minimum, two sides are the same length. So let's jump back up to equilateral. Are two sides the same length? Yes, I know there's three sides, but are there at least two sides that have the same length? Yes, it is, which means that an equilateral triangle can also be called an isosceles triangle. Look at that. I know, so simple, but who would have thunk it, right? So let's talk about scaling. Scaling, three are the same, two are the same. If you guess that none of them are the same, you are correct. No congruent sides. They're all different. I feel like that was super crooked. So I'm going to change it up a little bit. Scaling, none of the sides are the same. So I will put a marking here as 1, 2, and this one will be 3. That is telling us that all three sides have a different measurement. And the one thing that I want us to talk about when we talk about these sides and we talk about the angles is that we have to definitely classify the angles as what they are, and based off of these, they could be anything. But one thing we know that if I have a right triangle, we know one of the angles is 90, so the other two cannot be 90, but I know the other two could still be the same. So a right triangle can also be isosceles, because it could be 90, 45, and 45. I know, it's so simple. But then they could also have different, so it could also be a scaling. It could be anything. And that's the one thing is that we have to pay attention to. But the one triangle that no matter what, it's gonna always be this type of triangle every single time is an equilateral triangle. When we classify an equilateral triangle by its angles, they are always going to be called acute. Always. Because in order for it to be equilateral, that means the angles also have to be the same size. We're going to go ahead and put those markings here. If it's equilateral, all the angles have to be the same size because all the sides are the same size. which means that in order for these to be the same side, none of them can be larger than 90, and none of them can be 90. So they're always going to be acute. So equilateral triangles are going to always be acute triangles. And so when we talk about isosceles, we talk about the angles as well. So this one is this measurement, but the opposite is going to be the same. So these angles are going to be the exact same because they're opposite of those same angles. And in this one, they're all going to be different. So this one, all angles are different. For your practice on your own, you will have two parts of an assignment. In the first part, it will consist of 3 questions. You will use the graphic organizer that is to the left, or you may use the graphic organizer that was created throughout the lesson to answer the 3 questions listed on the screen. Part 2 of the practice on your own will also consist of 3 questions. You will use the anchor chart of the triangles that was used throughout our learning today to answer the questions for this portion of the practice on your own. You may use the anchor chart that you created during the lesson, or you can use the one that is visible on the screen to the left.